Hello, Dr. Wong. My name is Juliana Bahnan. I am a student in your AMP1 class, and I am doing this histology extra credit video today. And the slide that I will be focusing on, the image, is going to be of stratified squamous epithelium, is what I chose. The image that I am using is slide 25 on the Histology Pearson study guide slides. So this is, like I said, stratified squamous epithelium. I apologize for my makeshift video. My laptop was having some issues recording and putting the image over, putting my face over the image like a screen recording. So I had to resort to this, unfortunately. But hopefully I will make the image as clear as possible in my face while relating the information. First of all, this is stratified squamous epithelium. We know that epithelial tissue is classified by its layers and the shape of the cells. So we know stratified means many layers. It's multi-layered. Squamous is the shape. So the squamous cells, as you can maybe kind of see, they're flattened. So they're flattened cells. They have tight junctions, so they fit in together. That prevents things from coming in, penetrating, or leaving. And as we know, structure equals function. That is the golden rule. So we will discuss shortly how the structure of the shape of those squamous cells relates to the function that it performs. So here it's labeled nuclei, basement membrane, and the stratified squamous epithelium. So I will start with the stratified squamous epithelium. So essentially, we know that, the epidermis, well, first of all, we're going to be, I should have specified, we're going to be concentrating on keratinized stratified squamous epithelium. And there's also non-keratinized versions. We know those are found in the lining of the esophagus, the mouth, and the vagina. And we also know that the keratinized version, the keratinized, are found in the epidermis of the skin. We know that they are, it's avascular but innervated, meaning we don't bleed from the epidermis layer of our skin. But we do know it's innervated because we do need to be able to have a sense of touch and feel and know what's going on around us, feel hot, feel cold, so that our body can react accordingly and we can protect ourselves. So avascular but innervated. So essentially, we know that stratified squamous epithelium is the cells are dead, right? They're scale-like. We know that the purpose of this epidermis is to keep us safe. It's a protective barrier. It's very resilient. In day-to-day life, we experience friction, abrasion. We scratch our skin. We hit surfaces. And this outer layer, this apical layer of our skin, it's really fascinating. It protects us from all the elements, and it keeps everything together while keeping us stuff in as well. So you can kind of see it's as mentioned, it is stratified, so it's multiple layers, and we need that. It has to be robust. It has to protect us from mechanical damage, chemical pathogens, loss of water. It's just such a durable shield. And these squamous cells are flattened and almost scale-like, and they fit together in these tight junctions because it's an impenetrable barrier. It wants to be, so it keeps us hydrated inside. It keeps water from certain things from coming in, while keeping, us certain things inside as well. you know, and it's just a very fascinating role that it plays, and it's so crucial for us, you know, for our well-being. So, you know, that's the stratified squamous, the epidermis, multi-layered. And we know that these cells, they're filled with keratin, right? So they're keratinized. And we know keratin is a fibrous, strong protein. So all of these, you know, these apical, you know, these surface dead stratified squamous cells, they're filled with keratin. And, you know, this process called keratinization, it creates, you know, a waterproof layer that prevents the water loss. Again, we talked about tight junctions and keeping things together and whatnot. So yeah, that's the, you know, starting from the top down. So that's the top layer, the stratified squamous epithelium. And so this is labeled the nuclei. So we know that in the nuclei are located, you can kind of see, in the basal layer. Right, so epithelial tissue has polarity. There's a apical basal layer. So we know that this nuclei is located in the basal layer because in the epidermis, the cells are all dead, right? They, you know, they're dead. They're filled with keratin, and they eventually, we shed them. So these cells, you know, at the top, they don't have the nucleus. So we go down into the basal membrane, the basal layer, and we see these you know, these cells that are, you know, actively in mitosis, and they have nuclei because this epithelial tissue, this keratinized, you know, epidermis of our skin is continuously regenerating, where it's a constant cycle of regeneration. These cells are pushed up from the basement membrane, from the basal layer, and pushed to the surface. And you know, as they're pushed up, they, which we'll talk about in a second, you know, they do eventually lose their nuclei. But, you know, you can see here, there's many, many nuclei. You know, these cells are constantly regenerating. And we know that, you know, nuclei contain DNA that directs the activity for cell replication, you know, in this case. And we know that nuclei are predominant in active, you know, in inactive keratinocytes. But, you know, like I'm saying, like I said, as they mature, they basically, you know, go up to the surface and they lose their nuclei, and they just essentially like start dying, you know. You know, they slosh off. Eventually we shed our skin. So, you know, that's kind of the process of that, the nuclei, which we can see in this basal layer. And, you know, the process is crucial. Again, you know, these cells, they move towards the surface, they flatten, they die, they lose the nuclei, we eventually shed them. But this process is crucial. Process is crucial, you know, for the function of our epidermis. We need this constant regeneration of these cells. You know, because we experience so much friction, abrasion, and you know, whatnot every day. And, you know, those cells need to be able to regenerate themselves because they go through so much. They do so much for us. Okay, and then, so we can see at the bottom, the basement membrane. So this, the basement membrane, so again, we know that epithelial tissue has polarity. There is a apical basal layer. So the basement membrane is where like all the magic happens, right? So it's where all the party's happening. It's where the life is going on. So we have this basement layer, and you know, we know that the cells are in active mitosis. They're constantly being pushed from the bottom up to the apical layer. And as we just discussed, they die as they rise. But, you know, here they're still in active mitosis. And, you know, it's beyond that. So below the basement layer is the connective tissue. So we know that it connects, you know, it's an anchor that connects the apical layer to the connective tissue, because we know that all epithelial tissue rests on connective tissue. So this is kind of like the anchor that, you know, connects it to the connective tissue below. And it's, you know, it's responsible for tissue repair. It establishes that polarity of the epithelial cells in the apical basal surface. Yeah, and you know, I mean, it's not labeled, but we know below that there is connective tissue that supports, it binds, you know, and it's filled with cells, fibers, ground substance, and an extracellular matrix, you know, so it's a lot of fascinating stuff going on down there. And also, to note, we know that, you know, besides the epidermis, we know that the rest of the layers below are vascular, right? So the epidermis is avascular. These layers are vascular and innervated. And in the connective tissue is where we'll find the nerves and the blood supplies and whatnot. You know, so it's very fascinating. Stratified squamous epithelium, keratinized. It plays such an important and vital role for our bodies. And it's again, the structure absolutely equals the function for this. You know, so I think that this is just a really fascinating tissue. It does so much for us. And
nuclei.
You know, it protects us from pathogens. It protects us from chemical, you know, chemical substances, abrasions, a burn, you know, all kinds of stuff. It's really fascinating. And I hope I was able to enlighten you and show you my knowledge of stratified squamous epithelium keratinized. Thank you so much.